Hello, this is part 3 of a three-part documentary about Hellway, a game I developed myself. This video is going to be a little bit different from the previous ones. In this video I actually took, took care of writing some key points, which is gonna guide me through, and after that I'm going to match with some gameplay footage and maybe some debug images. So let's get started. One detail. So this is like the third take, which the first take was the first time I tried to record this video was all about showing code, explaining details, but yeah, this doesn't add a lot, right? My code is open source. I'm in the forum, so any doubt you have, if you do look at the code, you can ask me. So this video is much more about my personal experience developing for Atari. Some details, yes, about the code, but small and in a glance. So let's get started. So, the dream of making a game under less than 4 kilobytes starts with my love for emulation. My first computer was a Pentium, and I could not believe how many interesting Atari games I could emulate, and most of them under 4K, like Adventure, Combat, Heavy Raid, and so on. This project started in 2014 and was halted for 6 years. I kept the dream dormant. At the time was a very primitive kernel that could only loop the same cars. It was missing the most important part, a fast enough car generation algorithm that would make the game possible, right? So in 2020, I had a daughter, and within my complete lack of time, I started giving much more importance to time itself. In the very few free that I had, I decided to not postpone one of my oldest dreams anymore, to be able to code within the limits of 4K like the grandmasters of the past. So, programming for Atari is like getting close and intimate to a machine. For me, it's not like racing the beam, which is an excellent book by the way. It's more like surfing it. You don't want to get ahead, you want to ride it. So now I'm gonna talk a little bit about the internal game works, how the internals of the game works. So each track uses only 3 bytes. Each traffic line, right? Each track is a traffic line. Use only 3 bytes to keep its state, plus 1 byte. That's the most significant byte, plus 1. This is the kind of things you have to do while coding for Atari. I generate the cars on the fly, based on a very efficient hash algorithm. The 6507, which is the CPU of the Atari, have only one accumulator register. So I pre-calculate the value of the most significant byte in case I have a carry. So I don't have to store the accumulator back to memory or to use it with another calculation. I only choose what value to use and never update the memory during the drawing cycle. The traffic lines are like a very long pattern of cars, completely deterministic, and takes around 12 minutes to repeat. But consider all possible combinations with other lines, you're probably never going to notice the same screen twice. A little bit more explanation. So imagine that the cars are like a long tape. When I say they're deterministic, I'm not saying that I programmed the cars. It's algorithm that's generating them. But given the same start position, it's going to be completely consistent. Also, if you brake, you're gonna see passing through you the same cars that you passed by, right? So there is no random cars popping in, and you can also use this on your advantage, so you know the state behind you, even if you're not seeing. So yeah, so this was a little bit parenthesis. So those kind of crazy programming that you have to do for the Atari. My game bottleneck was always the drawing cycle, which included deciding what scanline contained cars for each line. My kernel repeats 3 scanlines, while it updates a memory cache for the next 3 lines. After all optimizations, my worst case was 229 cycles, and I just had 228. So these 3 lines, on line is 76 cycles, right? So the final solution was to replace the player card drawing routine that took 26 cycles to keep the state of when to start drawing the car, to actually make the car sprite 72 lines wide, or 72 lines of height. Yeah, so to make it a size of 72 lines instead of 7, padding with zeros, and always drawing the car sprite directly using the Y offset registers that contain the current scan line to direct fetch the value of the car directly from memory using these offsets. And now it's running 7 cycles, right? Because it's just a load with the Y register, which gives me the offset to the sprite. So I make almost no calculation. I completely lose my ability to move vertically the car, but I don't need to, right? Because it's all about relative speed to other tracks. So yeah, this was the perfect trade-off. And I have plenty of ROM space. Actually, I have more than 1 kilobyte left of ROM space, and I have about 48 bytes of memory. So I could do some other things with this code, I think. But I still hadn't had any great idea, and I think the game's on a releasable state. Hopefully. Yeah. So using rectangles was not exactly a design choice. It was a way to push the Atari hardware to its limits and use every object the Atari could draw in a line at once. This also explains the colors you see. You can have any amount of cars you want on each line, completely independent and without flickering. If the graphics are drawn by line, it means that they can have any height, so there is no limits per frame. The limits are per line. There is no concept of frame for the graphics, only lines. The border of the screen, I use the playfield. In the center, all the other objects, as a 8 pixels wide canvas. And the reason they are blocks is because 3 of them are just 1-bit registers. It means you can only change how wide they are, but you cannot put any kind of pattern into it, right? So yeah, and they are stretched to their limits. Player 0 sprite is your car. What you see as traffic lines are player 1 sprite, the ball, which have the same color of the playfield, the missile 0, which have the same color of player 0, missile 1, which have the same color of player 1. That's why the borders, the 2 traffic lines on the border have the same color. The traffic line number 2 have the same color of the playfield, and the traffic line number 3 have the same color of your car. Since all of these things can be at the same line at the same time, I didn't try to optimize or do any kind of technique to have more colors, because it's completely unpredictable when they're going to cross. And yeah, I want the performance to be completely stable without flickering. So the car turning the same color of the font, the heads-up display, is a design choice. But the third line with the same color of your car, so the third line to be the same color of your car is a hardware limitation, right? Because yeah, this is a player 0 missile, and yeah, it must be the same color of your car. So I could go on forever. There are many tricks that I had to apply while doing this game, like drawing half of the square each frame and flickering it to give you an illusion of a continuous text. But explain how to draw text would take more than 10 minutes, and this video is just about a fast overview. Just one quick thing about this technique. The really nice thing is that you only use 5 bytes of memory. So if I put the offset to the font in these 5 bytes of memory, the drawing cycle will just display whatever text I put it, and I just have to put five characters. I just have to define 5 characters for each frame, because basically it's alternating, right? So it's very cheap on memory, And also made it possible to load this on the fly and use a two lines kernel and use the full playfield, which I think is a kind of nice effect. For me particularly, I prefer than just using the 6-digit thing, which would not be a viable solution for me. The 6-digit sprite trick, which by the way, it's an amazing trick. If you guys don't know what I'm talking about, it's about how they do Discord in most Atari game nowadays, and Activision uses this a lot. I'm completely digressing, and let me go back to my original plan. The update cycle of the game is well optimized, so I can extend the drawing kernel to the limits of the overscan, gaining a lot of vertical space. I still draw the first line of score text and the last line of the car sprite on the recommended space of the Stella manuals to fit any television. This means that I still gain vertical area in most TV sets and emulators, resulting in a nice area behind the car. But if you have a very old television that crops a lot of the image, you're still gonna have a full playable game. Just not the best possible experience, but I try to give the best possible experience when I can. The parallax border is the only thing in the game that works close to a video buffer. Since it's a repeat pattern, I only have to cache 8 lines, which is actually 24 real scan lines, using 16 bytes of RAM, which is 12% of my RAM, right? Of my 128 bytes of RAM. So during the drawing, so this was pre-calculated during the blank, right? So during the drawing cycle, I direct copy these values to the playfield registers, repeating it every 8 lines. 8 lines of kernel, right? This is very fast to draw, and this way I could do this parallax with the very few cycles I had left, and also could completely abstract on the parallax effect. So basically, the reason we can select multiple parallax is that it just pre-calculates, and in the drawing cycle, I'm just doing drawing or whatever I pre-calculate on this memory buffer. So yeah, I'm not going to talk about more code and about this low-level stuff anymore. And if you're still here, I have some personal experience to share with you. So people call it low-level programming, but still there are so many abstractions you have. It is like this hardware was made with so very little amount of instructions. It's like this hardware was made to work with so very little amount of instructions that can do a lot with very little. Push 1 byte to one address, suddenly you draw a line of sprite. Push another byte, you change the background. Push another, and you wait for a scan line to end, and so on. The most impressive for me was the sounds. Atari is terrible at making music, but excellent at making noise. In one day, I wrote most of the sound routines, and they used less than 100 bytes of my ROM, which is nothing by today's standards, 100 bytes. I think it's way less than 100 bytes, actually, I have to count. So I can make sound directly using the game variables. So basically, all these engines sound like and things like that. It's just me reading, for example, the speed, using the most significant bytes to go to a table to choose what sound and what base frequency I use, and the other bytes, the other part of the byte is just changing the frequency, for example, or the checkpoint, like it's just the counter that I have to keep the score green, which I directly put as my frequency. So every time the counter decreases, actually my frequency increases, so it goes to a higher pitch. So we can direct. I didn't use any extra variables to produce sound. I just read the game state as sound. So this is more nice abstraction that the hardware gives to you, right? With very little, you can do a lot. That's the main reason this game can fit in 4K. Actually, this game can fit in less than 3 kilobytes. I would even say more. if I remove the squad drawing routines and some code that I don't need, or even maybe a Easter egg that I put it, I can reduce this thing to 2 kilobytes, like the very first Atari games. I'm not very interested in doing that. It was not my goal, but it is possible to do a fully playable version of Hellway with 2 kilobytes. Just, yeah, we're not gonna have this heads-up display, but the whole game is going to run. So, the closing thoughts. Now that's the real closing thoughts. That was my personal thoughts, right? Now that's my closing thoughts. Well, it got confused anyway, even with text written down. But let's continue. Coding for the Atari is amazing. It's like a wonderful, well-built puzzle. The CPU have very few instructions, most of them bit manipulation. You have only 76 cycles per scan line. You have a very limited number of objects you can draw per scan line. The hardware manual is very small, and the set of rules is very simple. The complexity comes not from the amount of parts. It's like a chess game. The game rules are easy to understand, but are harder to master. I found Atari documentation extremely simple, but you really have to think outside the box to make your 76 cycles you have per scan line count. If you want to build an Atari game, I encourage you. There's plenty of documentation and the community is amazing. For me, it is also a closing of a cycle. After learning functional programming, which completely abstracts the hardware, going back to the extreme opposite was very interesting thought exercise and broadened my understanding of computers in general. Coding for Atari is so fun that maybe that's the game. It's a meta game for sure. I want to end this video with a very special thanks to my wife for supporting me all the way. For my little daughter, Zelda, which turns 8 months old in a few days. She is my little angel, my little bundle of joy. During development, she took some of my time away, but gave me back so much happiness and energy, and I would like to dedicate this game to her. And thanks all the community, and a special thanks for the zero-page Homebrew folks for the amazing review and gameplay of the game. If you guys are getting better really quickly, and probably will do better than me soon. I hope not. Where's my pride is going to go, right? So, just kidding. Thank you. And goodbye. And that's it. I have no idea how many minutes I just talking. Oh my god, 18 minutes. Yeah. Goodbye, people. Nice. It was nice. It was very nice. Thank you. So I'm recording this after I finished the first recording, and this is just a small addendum. Programming for Atari taught me to look for the essential, to understand what's essential, what's score, what's really important, and then, just then, if you desire, adding superfluous stuff on top of a polished core. This also applies to life, and I recognize that several times in my life I didn't have this focus that programming for Atari gave me, and I will take this to my life. I will take this to my next projects. I'll take this to programming. I'll take this to my next gaming. To my next games, and this was a very important lesson to me. Thank you guys for watching.